Hi everyone, Miss Andronica is here and today we are comparing ratio. Okay, so equivalent ratios. These are similar to fractions, so to be able to compare ratios, you can bring them down to their simplest form to be able to see if they are in fact equivalent. If they are equivalent in their simplest form, that means they're going to be the exact same. So here's an example. Compare the ratios 140 to 60 and 28 to 12 to see if they are equivalent. So using common factors for both sides of the ratio to reduce it down as far as you can go, which is exactly what you would do with fractions. So 140 to 60. Straight away, if for nothing else, I can see that they're both even. So I know I can divide both sides by 2 and straight away I have a more simplified version. They're still both even, so I can keep going to divide by 2 again on both sides. I can see they both end in 5. Common factor is 5 straight away, so dividing by 5 on both sides, I get down to 7 and 3. 7 and 3 I know are both prime, so I can't possibly simplify any further. That is as far as it goes. Again, I'm going to go to the other ratio and I'm going to do the same thing. So I'm going to find a common factor between them. I can see that they're both even, so I can start there. Or I can also see that they're both divisible by 4. So 28 divided by 4 is 7, 12 divided by 4 is 3. Straight away in one step, I can see that yes, they are equivalent. Unitary ratios. If the ratios are different, so you don't get like 7 to 3 on both like we did in the question before, then that simplest forms are not always easiest to compare. So one method is using a unitary ratio. It is in the form of 1 to n or n to 1. Now, this may lead to a decimal. N here could be in a decimal form. This can happen only because it is for comparison purposes. It's not necessarily the final destination. It's often how we can then present our answer as a comparison. So let me show you what I mean by that in this example. We've got school A and school B. They're the students, they're the number of teachers in each. Which has the lowest student-to-teacher ratio? So this is where you can use a unitary ratio to be able to compare, and that's what I mean. It's not necessarily about, what is the unitary ratio. It's more about using it in order to be able to see which has the lowest student-to-teacher ratio. So when I look at these ratios, you've got school A is 265 to 12. Now, straight away, I can start to, see what common factors we have. Is there a 4? Is there a 3? Is there etc., etc.? Or I can jump straight to working out my unitary ratio. Now, as we saw up here before, it's always in the form of something to 1 or 1 to something. Now, if we want a student to teacher ratio, the easiest is usually, because that's student and that's teacher, the easiest is to divide to get the teacher, one of them, to 1. The easiest way is to get the smaller number to 1. In this case, for both schools, of course, it's going to be the teachers. So I'm going to take both sides in this case and divide by 12 so that I can get one of the sides to 1, the teacher side to 1. So if I do that on both sides, so for school A, that ends up being 22.08 rounded. Okay, if I do the same for school B, so it's 1,395 students to 56 teachers. Okay, again, unitary ratio, I'm going n is to 1, so I'm making sure that the teacher side is 1. So in this case, I need to divide by 56 on both sides to be able to get that teacher side to 1, and it'll be 24 0.91. Okay. So to compare, these are the two ratios here. Now, remember, I'm not presenting necessarily the ratio. What I'm answering is which has the lower student to teacher ratio. And I would say, well, the student to teacher ratio in school A is there's 22.08 students to one teacher. For B, it's 24.91 students to one teacher. So in this instance, with this data, we can say that school A has the lower student to teacher ratio. See how it's not necessarily the ratio that's the destination, it's which school. Looking at using percentages now. Another method to convert ratios is to percentages. This is helpful when you need to know one quantity as a percentage of another. So here's the method. Write them as fractions first and then convert to percentages. Let me show you an example. So we've got cake A and cake B. There's 250 grams of sugar and 530 grams of other ingredients in one cake, and 116 grams of sugar and 260 grams of other ingredients in cake B. Which cake is sweeter? Now, have a look at the hint over on the right. We've got, this is a question of proportions. So which has the greater proportion of sugar? So it's not about, looking at, okay, well, this is more because it's 250 grams. It's about looking at, well, what's the total in the cake? 250 grams of sugar out of how much in total? And that's not 530 because that's the other ingredients. This is an example of adding it all together. So 550 grams plus 250 grams plus 530 grams altogether is 780 grams. So in cake A, it's 250 grams of sugar out of a total 780 grams of cake. Okay, so this is sugar over the total cake. So I'm going to do that for B. I'm going to say that's how much sugar there is out of a total of how many grams of cake? 376. So I have to add the sugar and the other ingredients to get my total cake. Okay, so you just need to be careful with this method. What's the total? Is the question giving you the total, or do you have to work it out? Okay, once you get that, you've got fractions, convert to percentages, and we know how to do that. So numerator divided by denominator multiplied by 100. So the percentage is going to be 32.05%, taking it to 2 decimal places, and this is 30.85%, taking it to 2 decimal places. Once again, we're not finished. We need to answer the question, which cake would be sweeter? Now, percentage-wise, we can see that it must be cake A is the answer. It's got to be the sweeter one because that cake has a higher percentage and proportion of sugar than the other cake. Okay, that's it. Give it a go. Thanks, guys.